Alright, so in this video we're going to talk about loops. Some of the topics we're going to cover in this video, we're going to discuss incrementing and decrementing, and Java actually has increment and decrement operators. We'll discuss that. We're going to discuss the three main types of loops in Java, which is the while loop, the do while loop, and the for loop, and some things we can do with those loops, such as input validation, running totals, nesting loops together, and we'll wrap up with deciding which loop to use depending on what kind of situation you have. So our first topic is incrementing and decrementing. So the term increment means we want to increase a value by 1. The term decrement means we want to decrease a value by 1. We've seen these kinds of statements before. These statements here will increment the variable number by 1. So number receives number plus 1. And we also know the shortcut number plus equals 1. This one here, these statements decrement the number variable. So number receives number minus 1, number minus equals 1. There is actually a typo on the slide. This should be minus equals. I will fix that before I upload it to D2L. So incrementing and decrementing, right? We've said incrementing is increasing by 1, decrementing is decreasing by 1. Java actually provides us a set of operators. These are unary operators, which, remember, a unary operator only needs one operand. So we can increment and decrement variables with these unary operators. So if we want to increment, we use plus plus. If we want to decrement, we use minus minus. So down here are some examples. Number plus plus and number minus minus do the same thing as these statements here. So those are the operators that we use. And these will come into play when we talk about the for loop here in a little bit. So I'm actually going to show a code example on the increment and decrement operators. I'm going to switch over to IntelliJ. Okay, so here in IntelliJ, I have several code examples that I have already set up. They're all empty. I just have the files set up for time's sake. This first example here, I'm going to demonstrate how the increment and the decrement operator actually work. So we're going to do using those unary operators. So the first thing I want to do is turn caps lock off. I want to declare a variable. I'm just going to call this variable number, and I'm going to initialize it to 4. And I'll leave a little comment here. So number is going to start with a value of 4. So if I want to display the value that's being stored inside of number, which right now we know is 4, I can just do a print statement here. So I can say system.out.println. I can say number is, and just display its value. Right? I'll put a message here. Saying I will now increment number. Okay? So we've said the increment operator is a unary operator. And all we have to do to increment the number variable is say number plus plus. So number had a value of 4. When our program reaches this line, number's value will be increased by 1 or incremented to where it will now have a value of 5, right? So I'm going to copy this here. We'll redisplay the number. So we can say number is now some kind of value, and we can maybe decrement the number. Okay. So number had a value of 4. We display it. We add 1 to it. We decrement it. So now it should have a value of 4 again, right? 4. Incrementing takes it to 5. Decrementing will take it back to 4. And we can verify that by displaying it one more time. So if I execute this program, we can see my, oh, hang on, I'm debugging. I don't want to debug. Okay, so we can see number is 4. Now after we increment, it has a value of 5. Then we'll decrement it down to 4 again. So that's how this operator kind of works. Plus plus adds 1, minus minus subtracts 1. So moving on to loops. So what even is a loop, right? In our previous video discussion, we talked about decision structures, right? Or control structures. They direct the flow of a program based on some kind of condition, right? So a decision structure like an if statement will control the flow of a program if something is true or if something is not true. That's kind of the way that will direct the flow. A loop is a control structure that basically just causes statements or groups of statements to repeat. And like I mentioned earlier, we have 3 looping control structures in Java: the while loop, the do while loop, and the for loop. So the first thing we're going to talk about is the while loop. And this is kind of the logic of how the while loop works. We got to keep 2 things in mind with while loops. A while loop is going to have a Boolean expression that's going to be tested for a true or false value, just like an if statement has a Boolean expression. A while loop does as well. And then the second component is a statement or block of statements that will be repeated if our Boolean expression is true. So down here is kind of a flowchart, if you remember our flowcharts discussion. This portion right here is our while loop, right? So our program is running along. It's going to reach a Boolean expression. So while this expression is true, we're going to keep executing these statements, right? Over and over and over and over again. And then eventually, if this expression ever becomes false, we'll move on in our program. So what does a while loop look like? The general format looks something like this. This is just a screenshot I pasted in. So we have the while keyword, and then in parentheses we'll have our Boolean expression, just like an if statement, right? In an if statement we have the if keyword, and then we have our expression in parentheses. Same thing with the while loop. Then we'll have our curly braces, and any statements that we want executed will be inside the curly braces or inside the while loop body. The while loop works like an if statement that executes over and over again. A term that you might want to know is the term iteration. So each time a loop repeats, that is called an iteration. So the first time a loop executes, that's iteration 1. The second time it executes is iteration 2, so on and so forth. And with a while loop, as long as this expression is true here inside these parentheses, the conditionally executed statement or block will repeat, right? So if this is true, it's just going to keep repeating over and over and over again until this expression here becomes false. So I'm going to move back over to IntelliJ and do an example of a while loop. So here I have my while loop class set up with my main method already. And this is going to be a very simple example of a while loop. Let's say that I have a variable here called number with an initial value of 1. Here's where I'm going to put my while loop. So while number is less than or equal to 5, I want to display this message, right? So this will keep executing over and over and over again as long as number is less than or equal to 5, right? So I'm going to go down here and increment the number variable. So number starts with 1. And inside of our while body, we're adding 1 to it, right? So this will eventually end after 5 loops or 5 iterations. So if I run this code, we'll see that I have 5 iterations of my loop. If I change this to 10, we would have 10 iterations, right? And remember that this is only happening because of this increment here. If I take this out, we're going to run into something called an infinite loop. And we'll talk about infinite loops here in a second, but it looks something like this. It's going to keep printing out hello forever, right? It's going to keep doing it until I say, Java, you need to stop running. I'm going to put in the hotkey, which is Control C, or Control X, I think. Okay, so IntelliJ actually does not have the command line shortcuts. So what we're going to have to do is kill the process. We can hit the little stop button here, or we can X out here. It's going to ask if we want to terminate this process. Yes, I do. That's called an infinite loop, and we'll talk about that here in a second. But for now, just remember we can say number plus plus, and that will basically let us print out number 5 times. So back in our discussion, let's talk about the concept of a pretest loop. The while loop is an example of a pretest loop. And pretest loops basically just test their expressions before they iterate. A pretest loop will never iterate if the Boolean expression is false to start with. So we want to make sure that our data is initialized in such a way that the Boolean expression starts out as true. So let me go back to IntelliJ here. Remember, a while loop is a pretest loop, right? So this loop will never execute if this Boolean expression is not true to begin with, right? So let's say number has an initial value of 100, right? While number is less than 5, less than or equal to 5, execute these statements. Well, we know number is 100, which is definitely not less than or equal to 5, so these will not be executed at all, right? If I were to run this program, nothing will happen, right? Process finished, nothing happened, because it skipped right over it. And that's called a pretest loop. While loops test this expression before they execute anything. And we'll see what a post-test loop looks like later in the discussion. Like I said, an infinite loop, in all but rare cases, loops must contain a way to terminate within themselves. So basically something inside the loop needs to make that Boolean expression false, which in our IntelliJ case is this right here, right? Incrementing our number variable will eventually make it greater than 5. This is our way out of the loop. If we don't have that, we're going to get an infinite loop, which is what we saw earlier, where it was just printing hello forever, and we had to manually kill the process. That's what an infinite loop is. So input validation is a pretty big component of programming that we haven't really talked about so far, but we're going to kind of introduce it with our loops discussion. There's a famous saying when we're talking about programming, garbage in, garbage out. Meaning if you get garbage input into your program from a user, you're going to get garbage output, right? We want to try to make sure that we can get as little garbage input as possible. And we do that with the process of input validation. Input validation inspects data that is given to our program by a user and determining, is this valid or is this invalid input, right? So if we tell a user, enter in your age, right? And the user enters in the word cheese, the word cheese is not a numeric age, right? That would be invalid input. If we have good input validation, our program won't just crash because they didn't put a number in, but it will instead maybe tell them, hey, try to input this again and try inputting a number, for example. So a good program should give clear instructions about acceptable input, and we never want to assume that the user has followed these instructions, right? We can tell the user, enter in your age, please put in a number, but we never want to just assume that they're going to do that. Maybe they type their age out in letters, maybe they just put something random in, maybe they just hit the enter key and don't put anything in. We want to account for that, and that we do that with input validation. One way we can do input validation is with the while loop. Basically, if an invalid value is entered, we can use a while loop to require that the user re-enter it as many times as necessary, right? So if I say, give me a number, and they're putting in words, I can use a while loop and just say, okay, just keep looping until I get a number. Keep asking them for a number until they finally get it right. And I do have an example of that that we can show here. So this is just basically a very simple validation technique, and hence the name simple validation. Basically what we're going to do is we're going to get some input from the user. So I'm going to need the scanner here. So I'm going to import java.util.scanner. And I'm going to create my scanner object, right? Because I'm getting input from the user. I'm going to call my input variable int input here. And I'm going to ask the user to type something in, right? So I'm going to say system.out.print. Please enter a number in the range 1 through 100. Okay. And then we can say input receives kb.nextInt. So we've asked the user for input. We've stored their input in a variable. Now we can validate it. So is it what we asked for? Is it from 1 to 100? So I can say while my input is outside the range 1 to 100, and I remember from last week we talked about validating, or a couple weeks ago, we talked about checking if numbers were outside of a range. We use this OR operator. So if input is less than 1 or it's greater than 100, that means it's outside our range here, right? 1 to 100. So while the number is outside the range, meaning they put in something wrong, I'm going to keep displaying this message to them. Invalid input. Enter a number in the range 1 to 100. And I will keep assigning their input to the input variable until they get it right. Once they finally get it right, so once we're outside of our while loop, I'll just display whatever they typed in. And I'll close my scanner object. All right. So I'm going to run this program. It's going to ask me for a number from 1 to 100. I'm going to put in a wrong number right off the bat. I'm going to put in 560. We'll see that our while loop was triggered, right? While the input is not 1 to 100. I'm just going to keep doing it. Right? It's going to keep telling me that. I could put in -15, -20. It's going to keep asking me to enter the valid number, right? So once I finally put in a valid number, you'll see that we leave our while loop, our number is displayed, and our program ends. So that's kind of a simple example of file validation. I do have a more complex example that I want to show, but I did want to show the validation logic of kind of how this works before we go too far into that. So the very first thing that's going to happen when we're doing input validation is we're going to read the initial value, right? We're going to read a value from the user first, just like we did with our example just now. After we read that first value, we're going to start our while loop here. And this first read, like it says here, this is called the priming read. And that's just a term that you may need to know. But the priming read provides the first value for the loop to actually test. So enter a number, right, from 1 to 100. Our priming read will read that number from the keyboard or from the user. Then we can start testing it, right? So is the value invalid? Is the number outside the range 1 to 100 in the case of our example we just did? If the case is yes, display an error message and read another value. And then we're going to keep doing that over and over and over again until we hit the question, is the value invalid? No, they finally got it right. Okay, we're going to leave our loop. This is kind of the logic of input validation. And I do have a pretty, a more lengthy example of input validation here. I'm going to close these files out. Okay. I have a little bit more lengthy of an example, but this one's kind of more applicable and has a little bit of a scenario. So this class is going to calculate the number of soccer teams that a league may create from the number of available players. And we're going to use input validation with some while loops here. So the first thing I want to do always is to create my scanner object. I'm going to do some constant variables here just to remind you that they exist. If I use the final keyword, that means I can't change the value of this variable for the rest of my program. So we'll say that I have a final variable or a constant variable describing the minimum number of players that can be on a soccer team, and that value is 9. I'm going to have another one for the maximum number of players that can be on a soccer team, and we'll say that's 15. So this is the minimum number of players per team, and this will be the maximum number of players per team. And I'll just create some more variables here. So I'll have an int players, and this is just going to be my available players. I'll have an int for team size, the number of teams that we're going to have, and if there are any players left over, we'll store those in here as well. So the first thing I want to do is I want to get the amount of players per team. I'm going to get the number of players per team. I don't like amount. So we'll ask the user for some input, right? System.out.print. Please enter the number of players per team. So we can say our team size is going to be kb.nextInt. Right? So we're asking the user, how many players do you want per team? And here we're going to have to do some validation, right? Because we know that the minimum number of players is 9 and the maximum number of players is 15. So we're going to have to validate that input to make sure that it's in that range. Validate the number entered. And basically we're asking the question, is it in the range 9 to 15? So remember with validation, we're going to use a while loop. So while the team size is outside the range 9 to 15, and remember min players is my constant variable with a value of 9. So while team size is less than 9, or while team size is less than or greater than our maximum number of players, which is 15. And remember, this is basically saying, while the input is wrong, or what we're not looking for, we want to ask the user to actually input the correct stuff, right? So I'll say system.out.println, and I'll say something like this: invalid input, team sizes range from, close that down. We'll say team size ranges from the minimum number of players to the maximum number of players. So if we go back to what we were just looking at here, our logic, is the value invalid? The first thing we want to do is display an error message, which we've just done, right? Is the value invalid? If the answer to this is yes, I want to display an error message. The second thing we want to do is to read another value. So I will ask the user to input another value. Right? So we're telling the user what was wrong, right? If they put an invalid number in, we're going to tell them why. So the team sizes range from this value to this value. We're going to ask them to input another value, and we're going to store that in team size. And this while loop will keep executing over and over and over again until this is false, aka until they get the input right. So then what we'll do is we'll get the number of available players from the user. All right, so we're going to ask the user how many players are available, and we can assign their input to the player's variable. Then we'll validate. And we want no negative values here, is basically our only validation. We don't want there to be negative 20 available players, right? That doesn't make sense. So we can validate that. While the value inside our players variable, which is what the user has just typed in, is less than 0. And again, if you want to think about this in a different verbiage, you can say while the user has entered a negative number, ask them to enter a non-negative number. And we can say something like the number of players must be non-negative. And we can say enter 0 or greater. And then we'll just assign their input to the players variable yet again. Right? So let's take a look at this with our logic here. Is the value invalid? In this case, is the value negative? If the answer to that is yes, we'll display an error message. We'll read another value from the user, and then we'll test that value. Is that value negative? If the answer is yes, we'll display the error message again, read another value again, and then we'll test it again, right? And this will happen over and over and over again until the value is finally considered valid, which in our case here, meaning it's 0 or greater. And then we can just do some calculations here. So we can calculate the number of teams. And we can just say our teams is going to equal our players, the number of players, divided by the team size. If we have any leftover players, we want to account for that. So we can use the mod operator. Remember, mod gives us leftover or remainder values for integer division. So we can say leftover receives players mod team size. And then we'll just display the results. So I'll say something like system.out.println. There will be this many teams with this many leftover players left over. And I'm going to close my scanner. And now I'm finished. So I've done two separate validations here. I've validated if the input is in a range from 9 to 15. And down here I've validated if the input is a positive number or a non-negative number. So I'll run this. It's going to ask me for the number of players per team. Let's put in 60 players, which is way outside the range. And we do see that our input or our error message is being displayed. Invalid input, team sizes range from 9 to 15. I'm going to do it again. I'm going to put 1. And you'll see that just like before, it'll keep giving me the error message until I actually put in a correct number. So let's put in 10. Now it's asking for the number of available players. We said if it was a negative value, that was what would trigger our validation input loop, which it looks like that's working. I'll say that I have 50 available players, and we can see there will be 5 teams with 0 players left over. So that's a little more in-depth example of how to use input validation using a while loop. Another kind of loop we have is the do while loop. And this loop is very similar to the while loop, but it has a big difference. This loop is a post-test loop. Remember we said the while loop was a pre-test loop. In a do while loop or a post-test loop, our expression is actually going to be tested after each iteration. So a while loop tests the expression before the iteration. A do while loop tests the expression after the iteration. And it kind of looks like an inverted while loop. This is a screenshot of what a do while loop looks like. Weirdly enough, and it's kind of hard to remember all the time, we do terminate a do while loop with a semicolon. So I do have an example of a do while loop. And this is a pretty simple example of how they work. But the first thing we're going to do is we'll just set up a variable here. I'm going to call this x and give it an initial value of 1. And we'll say do these statements, do these statements while our condition is true. So I can say while x is less than 0, semicolon, do these things. So maybe I just want to display the value of x. Now notice that the value of x is 1 here, right? Well, our while Boolean condition says execute the statements while x is less than 0. Well, 1 is not less than 0, right? 1 is greater than 0. So this expression will result to false. But because a do while loop is a post-test loop, meaning it tests the expression after each iteration, this will actually execute 1 time, even though this is false. So if we run this, that's the wrong file. If we run this, we'll see that it's displaying the number once, then it's validating, is x actually less than 0? No? Okay, then I'm not going to execute again. Right, now if our statement said while x is less than 10, we could modify this a little bit, and we would see that we're displaying x as it increments using a do while loop. Works very similar to a while loop, with the key difference being it is a post-test loop. And what that kind of means for usage is use a do while loop anytime you want to make sure that it will execute at least 1 time. So like this says here, the do while loop is a post-test loop, and as a result, it will always perform at least 1 iteration, every time, at least 1. Even if, like we just saw, if the Boolean expression is false to begin with. Right? Here, our Boolean expression is false right off the gate. X is not less than 0, but this will still execute 1 time. like we've seen, this kind of differs from the behavior of a while loop, because while loops are pretest loops. And like I said, use a do while loop if you want to ensure the loop will execute at least one time. Now I'm going to do a little bit more of an in-depth example of a do while loop. And we're going to do something called a user-controlled loop, which basically gives the user some kind of degree of control over how many times the loop will iterate or not. So to do that, if we're having user input, we need to use some kind of input gathering method, which here we're going to use the scanner. I'm going to create my scanner object. And this program is going to take in some test scores, as many test scores as the user wants to enter. It's going to calculate the average of those scores, and it's going to display that to the user. So it's going to, first we need to set up our variables, right? So I'm going to have 3 scores. Then I'm going to have an average to actually average those scores together. I'm going to have a character variable here that is going to be what we use to determine if the user wants to repeat the test score gathering or not. And this is going to take the user's input. So the first thing I want to do, I just want to display some kind of message. We'll just say something like, this program calculates the average of 3 test scores. All right, so what we're able to do with this do while loop is we're going to be able to get as many sets of test scores as the user wants. So I'm going to set up the do while loop here. Right, and I want to do the things, right? I want to do these statements as long as the user is entering the letter Y, right? Y for yes. If they enter the letter N for no, or any other letter besides Y, I don't want to keep repeating this. So while my repeat character is equal to the letter Y, and I'm going to say lowercase y or capital Y here. So while these are both Y, I'm going to keep executing. So now I can actually fill out this do while loop. So the first thing I want to do is get the first test score. And I can say something like enter the first score or enter score number 1, something like that. Then I can say score 1 receives kb.nextInt. And I'll do that 2 more times, right? Because we have 3 test scores. That didn't do what I wanted it to, but that's okay. All right, so here I want to get the second score. I'll change my message to say enter score number 2. And I'll make sure that's my score 2 variable. Here I'm going to change this to 3s. And we're good to go. So we have messages asking the user for input. We're storing their input in these variables. Then we can calculate the average, but first I want to consume the new line. If you remember from our lab, I showed the keyboard buffer kind of what that looks like. We still have a new line character floating in our keyboard buffer because all we've been reading are integer values. And we're going to need to consume that new line character so we can take in the letter yes or the letter Y or the letter N, right? Because that's a next line. So that's how we do that. We're going to get rid of that new line character so we can take in string input. I'm going to calculate the average of my 3 test scores. So to my average variable, right, which I declare up here, to my average variable, I'm going to assign the result of score 1 plus score 2 plus score 3 divided by 3. And that will give me the average. And then I can display that if I want to. So I could say system.out.println, the average test score is this, is the value in our average variable. I'm going to print a new line just so my output doesn't look so bad. And then here I'm going to ask the user if they would like to continue or not. So system.out.print line, would you like to continue? Or I'll say something like this. Would you like to enter or average, would you like to average another set of test scores? I'll have a second message that says enter Y for yes or N for no. My input, which is a string, right? My input is going to be kb.nextLine. And again, that's kind of why we did this new line character, so we could actually read in a string value. Our repeat variable, however, is not a string, right? It is a character. And if you remember from our string methods that we have, one of our string methods is character at, the char at or char at, however you want to say it, method. So we can say our repeat variable is going to receive input.character at index position 0, right? We just want that first letter. If it's a Y, then we're good to go. If it's an N or anything besides a Y, our loop will just end. So this method here, I'll put a comment here if you look at this later. This gets the first character in the input string. So let's run this. Enter score number 1. I'll say it was an 80, score 2 was a 90, score 3 was 100. We'll see that my average test score is a 90. It's going to ask me, would you like to average another set of test scores? Enter Y for yes or N for no. I'm going to put in Y. There's my 3 set of scores, and we'll see it's going to keep asking me if I want to average another set until I enter the letter N, at which time my program will end. And notice that it went through this one time before it asked me if I wanted to continue, right? That's kind of why a do while loop is useful. It lets us go through something at least once before we start testing. So the logic of a do while loop is shown here. The first thing that will happen is the statements of the loop will be executed. Then its expression will be tested, right? If that expression is true, we'll keep going through our do while loop. This is very different than a while loop, which tests first and then executes statements. A do while loop will execute the statements first and then start testing. We do have some different types of loops. Our 2 main categories that we use in in programming, we have conditional loops and we have count-controlled loops. And a conditional loop will execute as long as a particular condition exists. While loops and do-while loops are conditional loops, right? So an input validation loop, such as a while loop, will execute as long as the input value is invalid, which we've seen in some of the code examples. Conditional loops, though, we don't have any way of knowing how many times these loops will iterate, right? A user could get the input right on the first attempt. It may take them 70 attempts. We don't really have a way of knowing that as the programmer, how many times that loop may iterate. Sometimes, though, we do know the exact number of times we want our loops to iterate through. And a loop that executes a specific number of times is known as a count-controlled loop. So, for example, if a loop says enter sales amounts for each month in a year, we would know that we want to iterate through that loop 12 times. Once per month, yeah, for a year is 12 times. Count-controlled loops must possess 3 elements. They have to have 3 things in order to be considered a count-controlled loop. The first thing is a control variable has to be initialized to a starting value. Remember, we discussed control variables before. Control variables determine how many times a loop is going to be executed. So the first thing a count-controlled loop must do is initialize that or set it to a starting value. The second thing count-controlled loops have to have, that control variable has to be tested by comparing it to a maximum value. When the control variable reaches that maximum value, the loop will terminate, right? So if you start your control variable at 0 and your maximum value is 5, your loop will iterate 5 times, right? And the last thing it has to have, it must update the control variable during each iteration. This is usually done by incrementing the variable, which we've discussed is just adding 1 to it, right? So these 3 things have to happen for something to be considered a count-controlled loop. And the best example of a count-controlled loop is the for loop. In Java, the for loop is the most ideal way to write a count-controlled loop. It's specifically designed, it's like by design, it is useful for count-controlled loops. So it has built-in initialization, testing, and updating, which were, like we said, the 3 things that they need. The format of a for loop is shown here. So we have the for keyword, and then in parentheses, we have our 3 things that we need. The first thing is the initialization, the second thing is the test, and the third thing is the update. And then in our loop body, inside these curly braces, we have as many statements as we want. So here in IntelliJ, I have my for loop example file. This file has a lot of comments in it. This is for your benefit. If you go back and look at these code examples, these comments will maybe refresh you on some of these things. So the first thing that we want to do is declare our control variable. I'm just going to call this int number. So remember, declaring the variable is giving it a name and a data type. So number has been declared. If I know I want to print hello 3 times, right, I can use a for loop for that. So I can say for, the first thing that's going to happen is the control variable is initialized to a starting value, right? So I'll say number is assigned a starting value of 0. The second thing that has to happen is the test. So as long as number is less than 3, I will iterate through. So my maximum value is 3 here. My test is number is less than 3. And the final thing is the update, which we said 9 times out of 10 will be incrementing our control variable. So I just say number plus plus. All right, so that's my for loop header.
Then I'll add my braces. And for my body, I just want to print hello 3 times. So I'll say system.out.print, print line. I'll display number so we can see exactly how many times we are printing it. Put a semicolon here. And if we execute this program, we'll see that I have printed hello 3 times. Now the reason it's showing 0, 1, and 2 is because my control variable was initialized to 0. If I set it to 1 and make sure number is less than or equal to 3, that should give us the output that we want. There we go. So the for loop, built-in initialization, right? We initialize our control variable. Built-in testing, we're making sure the control variable, we're going to keep looping until the control variable reaches some maximum value. How is it going to reach that maximum value? We're going to add 1 to it every time we increment, or every time we iterate. The logic of the for loop looks something like this. So let's say we have a control variable called count. That's the name of our control variable. In my code example I just did, my control variable was called number. Here it's called count. So I'm going to assign 1. I'm going to initialize count with a value of 1. My test is as long as count is less than or equal to 5, I'm going to keep looping, right? So I'm going to have some print statement. I'm going to increment count by 1. So now I'm coming back up here. Now count is 2, right? So I'm going to go through my loop, increment count by 1. Now count is 3. Loop again, it's 4. Loop again, it's 5. Once count is 5, it does not pass this test, right? 5 is not, well, it would need to be 6. So we'd go through, increment it by 1. Now count is 6. So now we're going to test one more time. 6 is not less than or equal to 5, right? It is greater than 5. So that would let us leave the for loop. That's kind of how logically the for loop is structured. And I do have a good example of a for loop here, a little more in-depth example. So this file is just going to display some squares using the for loop, and squares like mathematical squares, so a number squared. So the first thing I want to do, I want to add a little header here, a little header to our display. I'm going to use the tab escape character. So I want 2 tabs. And then I'm going to say number squared. And I'm just going to add like a horizontal line underneath there, maybe. And here I'm going to say display the squares of 1 through 10. I'm going to come back to what this comment is referencing here in a few minutes. But we know the for loop has to initialize the control variable. Well, we can actually declare and initialize the control variable in the for loop header. So I can say for int number, right, which is a declaration. I'm giving a name and a data type. And I'm also going to initialize it. All right, so we can do that. What happens when we do this, though, if you remember in my discussion about variable scope, number here is restricted to this for loop and this for loop alone. I can't use number outside of the for loop because I have declared it here inside the for loop header. My test, we said, is 1 through 10, right? So my test will be as long as number is less than or equal to 10, I will keep iterating and I'm actually going to increment number by 1 every time I iterate. Okay. And here I'm just going to print out these squares. So I'm going to print out number. I'm going to print out 2 tabs to match what I have up here, and we'll see what this is doing here in a second. It's basically just making my output look pretty. And then I'm going to display the number squared, which is just number times number. All right, so if I run this program, what those tabs were doing, right, is they were giving me some tab spaces here. I actually think I need one more up here. Or no, I think I need one more down here for it to look how I want. There we go. So those tab characters are just giving me tabs in my output. So the number is 1. 1 squared is 1. When the number is 2, 2 squared is 4. When the number 3, 3 squared is 9, on down our list. Okay. So that's an example of a for loop. Remember that it has to have 3 things: initialization, testing, and updating. We can also declare a variable and initialize that variable in our for loop header, but that restricts this variable to only this for loop, right? I can't use number outside this for loop anywhere. I would have to declare it again. The for loop is a pre-test loop, just like the while loop. It's going to test that expression before it performs an iteration. So if you hint, hint, if you see on a quiz, is a for loop a pre-test or a post-test loop? It's a pre-test loop, right? It's going to test this condition right here, number less than or equal to 10, before it executes this at all. So if I gave number an initial value of 100, the for loop is going to test, is 100 less than or equal to 10? No, it's not. I'm not even going to execute any of these statements. That's a pre-test loop. Some things we want to avoid. We want to avoid modifying the control variable in the loop body. We want to avoid placing statements that modify the control variable in that for loop body, okay? Any modification of the control variable should only take place in our update expression, and that's automatically executed at the end of each iteration. So if I go back to here, we don't want to be changing number down here. I don't want to say, okay, well now number is going to be, now number is going to receive 4. Right, you would want to change the value of your control variable or modify that value in any way. You want to avoid doing that. That's because it can mess up your iteration count. This statement right here increments number by 1 automatically every time you iterate. At the end of each iteration, 1 is going to be added to number. And that's all we really need to worry about in terms of modifying our control variable. Just keep it to this right here. And like I mentioned, we can actually initialize and declare a control variable in the loop header, right? If we're going to use a control variable in the loop, and that's the only place we're going to use it, it makes sense to just declare it in the loop header instead of at the top of your program or something. Sometimes we can allow the user to control how many times a for loop will be executed, right? We talked about user-controlled loops with that do-while loop earlier, but we can also allow them to control for loops to a degree as well. And we do that by allowing the user to set that maximum value. Remember, our tests and our for loop have a maximum value. If we let the user set this right here, that determines how many times our loop will execute, and we can allow them to do that. So I'm actually going to do the same code we just did, right? Squares, but I'm going to add a little something to it. So I'm actually going to copy all of this code right here. And I'm going to paste it here in user squares. Because the program is going to essentially do the exact same thing, but we're just going to add in a component of allowing the user to enter some data here. So I'm going to import java.util.scanner. I'm going to create my scanner variable. I'm going to allow the user to enter in a number here. So I'm going to call this max value. I'm going to get that max value from the user. So I'm going to say system.out.print. How high should I go? And I'll say max value receives kb.nextInt. Now, down here in my for loop, instead of hard coding 10 here, right, I want to display the squares from 1 to the max value. So if the user enters 40, I want to display all squares from 1 to 40, which means instead of having this 10 here, I'm just going to replace it with the value of whatever is in that variable. Other than that, our code stays the exact same. So I can run this program. How high should we go? Let's say I only want to go to 3. We'll see that our for loop only iterates 3 times. If I say I want to go to 100, we'll see that our for loop iterates 100 times, right? So that's a user-controlled for loop. And again, if we want the user to control a for loop, they really are controlling the maximum value in our test section of our for loop header. All right, so a few more things we can do with loops. We can do something like keep a running total. And a lot of times that's the case that you'll want to do that in your program. You'll want to keep like a running total of a series of numbers. Like let's say we're calculating a business's total sales for a week. The program would want to read the sales for every day from the user, and then it would just tally up those totals as a running total. Programs that calculate total series of numbers typically use 2 elements, right? We've got some kind of loop that's going to read the numbers, and then we're going to have a variable that's going to accumulate the total of the numbers as they are read. And that variable that accumulates, we call that an accumulator. The loop will keep the running total because the accumulator is storing the total as it reads through each number. So I do have like a logic here, and I'll do a code example. So the logic of a running total loop, you have your accumulator variable, which is initially going to be 0. Is there another number to be read? Yes, right? So as long as that's true, read the number and then add it to the accumulator, right? So you're adding on to this accumulator variable over and over and over again. It's building up its value until there are no more numbers to be read, and then you can display the final value. So the code example I have for a running total, let's see, is this total sales file here. So this is going to demonstrate an accumulator using a for loop. And I'm going to be taking user input, so I've already imported the scanner class. I'm going to set up my variables here. So I'm going to set up a variable called days. I'm going to set up one called sales, and I'm going to set up one called total sales. Total sales is my accumulator. It's going to hold or accumulate, hence the name, a running total value. So I'm going to create my scanner object here, link it to the keyboard. We have to initialize the accumulator. Anytime we use a variable inside of a loop, we have to initialize it first. And we said we always initialize the accumulator to 0. So total sales has an initial value of 0.0 because it's a double. Okay. So let's kind of refresh user-controlled for loops here. I'm going to get the total number of days from the user. And I'll say something like, for how many days do you have sales figures? We'll assign that to the days variable. And if they put in 10 days, I want my for loop to run 10 times. If they put in 3 days, my for loop's going to execute 3 times. All right, so we have to put that as our max value. I'm going to declare my control variable and initialize it. My test is going to be as long as my control variable is less than or equal to the number of days that the user typed in. And my update is just going to be an increment, just like before. So while I'm in my for loop, I'm going to ask the user, please enter the sales for day, whatever day we're currently on in our loop. So our first iteration, it will say, please enter the sales for day 1. Our second iteration, it will say, please enter the sales for day 2, so on and so forth. Then we can say our sales variable will receive kb.nextDouble. We're going to actually read the sales from the user and add it to our accumulator. Remember, plus equals is the same thing as saying total sales receives whatever is currently inside total sales plus whatever is inside sales. These two lines of code do the same thing. I like this one because it's shorter. So we're going to do that, and we're going to keep adding on to total sales for however many days the user specified. Then we can display the total sales. I'm going to use printf here just to refresh you on that. So the total sales are going to be formatted, right? I want to format them to look like a decimal value. So our formatter always starts with a %. I'll put a comma there if it's big enough. 0.2 for 2 decimal places. F because it's a floating point number. Comma because I have to tell Java, here I'm saying, hey, I'm going to format something. Over here, I need to actually tell Java what I'm formatting. In this case, it's my total sales variable. And I'm going to close the scanner object. So if we run this file, how many days do we have sales figures? Let's say we have sales figures for 4 days. Enter the sales for day 1. Let's say it was something big. Day 2 maybe wasn't quite as big. Day 3 was the biggest day yet. And day 4, we made $1. So we'll see that our accumulator took each of these values and added on to our accumulator variable, which is what is displayed here. So that's kind of how an accumulator works. So that's kind of how total logic, running total logic works. Let's talk about a Sentinel value, which is just a term for a special value that cannot be mistaken as a member of the list. And the Sentinel value will signal that there is no more values to be entered. When the user enters the Sentinel value, the loop will terminate. So I've got an example of a Sentinel value that we can talk about. This is called soccer points here. And let's just say we have some variables. We have an integer for points. My accumulator, right? I have to initialize it. If I want to use it inside of a loop. Set up my scanner. And I could leave a message here that says something like, enter the number of points your team has earned for each game this season. And I can leave another message that says, enter -1 when finished. So this right here is basically just like a prompt, kind of telling the user what's going on. I'm going to put a blank line before I actually ask them for input. Here I'm asking the user for input. Enter game points or -1 to end. Then I'll actually read their input. So I'll say points receives kb.nextInt. And my Sentinel value is -1, right? -1 is never going to be part of my points because you can't have -1 points. -1 is a Sentinel value. When the user enters -1, my loop will terminate. So I can say while points is not equal to my Sentinel value or -1, I'm going to add to my accumulator, and I will ask the user to keep entering points. Or -1 to end. Forgot my quote. All right, so my loop will keep running until the user enters -1, which we say up here in our while Boolean test, right? While points is not equal to -1. As soon as the user types -1, we're kicked out of the while loop. At which point we can display the total points if we want. So system.out.println. Total points are this value. Close my scanner. And we can run this. So if I run this program, we'll see my kind of message describing the program. Here it's asking me for input. Enter game points or -1 to end. So this will let me enter input forever. It will let me go as long as I want to go. As soon as I feel like leaving, all I have to do is type -1 or that Sentinel value, and it kicks me out of the loop, displays my accumulator value, and our program is over. So that's kind of what a Sentinel value does, is it allows you to exit a loop because that number will never be part of your valid set. One of our last topics here is nested loops. We can actually nest loops inside of other loops, just like we could with if statements. Sometimes that's necessary if a task performs a repetitive operation and that task itself must be repeated. So like if you think about a clock, that might be a good example of something that would work like a nested loop, right? You have hours, minutes, and seconds. Every hour has minutes that are ticking up to 60, every minute has seconds that are ticking up to 60, right? So that's something that would work like a nested loop. I do have an example of a nested loop to show you with our last code example for this week, which is going to be this test average 2. It's going to be a little different than the first test average that we looked at. So I know that I'm going to take some input from the user. I'm going to set up some variables here. This time I'm going to account for the number of students. I'm going to account for the number of tests. Right before I only allowed for 3 tests. Here I'm going to allow the user to say how many students they have and how many tests per student. What's the score for the test? This is my accumulator. And this will be my average test score. I'm going to set up my scanner, link it to the keyboard. Here I'm going to get the number of students. Then I'm going to assign the number of students to my numStudents variable. Here I'm going to ask how many tests does each student have? Right? And then I'll assign numTests whatever the user types in. So kb.nextInt. So here is where I can say, for every student that I have, I want to enter in their test scores, right? And because we've given the user a very high degree of flexibility here, we can use a nested loop to make this a lot easier on ourselves. So for every student that I have, right? So for int student, I'm going to call my control variable student here. I'm going to give it an initial value of 1. I want to keep looping through the students until we reach our maximum value, students plus plus, or student plus plus. So each student is going to have their own accumulator, right? Each student will have their own average test score. So I'm going to initialize this per student. Then I'm going to get the test scores for a student. And a lot of this may look confusing, but it's for output purposes to make our output look better. So for this student, right, so I'm basically printing out student number 1 on our first iteration, and then I'm going to allow the user to enter in student number 1's test scores. So however many tests we've said that we have, we're going to loop that many times, right? So we said get the number of tests per student. If the user says 3, our test for loop is going to loop 3 times. I'm going to declare and initialize my control variable to 1. Keep looping until it is equal to or less than or equal to my maximum value. And I'm going to increment by 1. So for every test that we have, I want to ask the user to enter in that score. And we'll say score receives kb.nextInt. And we'll add to that accumulator. Once we get all of the students' tests, right, we're still inside our student for loop here. Once we get all of this particular student's tests, we can calculate their average. So calculate the student's average and display it. So the average here will receive the total, which is what we have here, divided by however many tests the student had. And I'm going to do a printf just for display purposes. We can say the average for students. %d is a digit value, like a numeric value that you want to display, and we'll see what that looks like here in a second. We know our decimal one. Instead of 0.2f, I'm going to do 0.1f. I only want one decimal place here, just for fun. And I'll add a couple of new lines. The first thing I want to format is my student number. The second thing I want to format is my average test score. All right, and then at the very end, I'm going to close my scanner. Let's put all this together. This might be kind of confusing unless you take a look at it and kind of play with it on your own. But let's see what we're doing. How many students do we have? I'm just going to do 3 because if I do more than that, it might take a long time. How many tests per student? We'll say 3. So, student number 1. Please enter the score for test 1. Let's say it's an 86. Test 2 is an 85. Test 3 is a 100. So the average for student 1 is 90.0. All right, so our loop process is for the student, we're going to get 3 test scores, which we saw right here, right? For student number 1, we got 3 test scores. It displayed the average, right? Once we display the average, this iteration is done. So we go all the way back up to our second student, student number 2. It's going to ask for their scores. Right, we go through this whole process, go all the way back up to student number 3. And we'll calculate their averages by doing this for loop. It's going to display the average. And because we only wanted to iterate 3 times, right, we only said we had 3 students. So our num students was 3. Once we've iterated 3 times, our program is over. So that's kind of how you nest loops. The last thing I want to discuss is deciding on which loop you should use in which situation. Each one of Java's loops, the while, do while, or the for loop, is equally useful depending on what kind of situation you're in. So the while loop is best for input validation, and if you don't want the loop to iterate at all if the condition is false from the beginning, right? So if you want a pre-test loop, you could use the while loop. It's also ideal if you want to use a Sentinel value to terminate the loop. Remember those Sentinel values we said was like enter a number, enter -1 to exit the loop. That would be a good use for a while loop. The do while loop is useful for all the same reasons as the while loop, but it has the added benefit of it will always iterate at least once. If you don't want it to iterate at least once, like if your condition is wrong, don't use a do while loop. The for loop is ideal for situations when you know the exact number of iterations that you're going to make. If you know I need to iterate 15 times exactly, you could use the for loop. Or if you want the user to be able to have some say over it. So, how many names would you like to enter into this roster? The user types in 10, right? At that point, your program knows, okay, I'm going to be looping exactly 10 times. So that's a good use for a for loop. So that's all on the discussion for loops. Next lecture video I make will be on using some different Java classes. We'll revisit the math class. We'll talk a little bit more about strings. We'll talk about how to generate random numbers and stuff like that. All of the code examples from this video I will put on my GitHub, and I will link that in the description, as well as upload them to D2L.